Hello everybody and welcome. And in today's video I'm going to be adding a crawler and maybe some splices to the crawler to this here gold room. Just get rid of that one over there. Good. And we're going to head on over to a nice direct view. So for this here crawler we are going to be using a standard 203 by 133 beam. And we're going to call it CB or CWB. Doesn't really matter. Yeah, that should be good enough. Now the crawl beam that we are going to be using is going to run all the way from out here into this area over here. I'm just going to put it right down there. And then it's going to run from down here up, over and back down again. Specifically, it's actually going to be two different crawls, as they're going to be handing off material between each other. Let's get that out of the way. So, for our crawls over here, I'm going to go ahead and put in a construction circle from the center to my construction line, and then I'm going to move it down. And that's going to give me my little hoop over here. Now, steel, we are going to be using the poly beam to create our half circle effect over here. And it's going to come from here at the beginning. Let's just take a standard beam. It's going to splice over here. From here, we're going to go over to our poly beam, which is going to run straight for a little bit to about here. It's going to curve off right up to here and go another 125 to there to create this bit of a half circle. We're going to grab this point over there and make it into a half circle, and that'll give us our rounded end. Of course, the other way of doing this is to use the chamfer instead. So what you would be doing is starting off same as last time, going right to the corner, right to the center to form a square. I'm going to grab that node and I'm going to say we want it like a rounded by a meter, and that's basically going to create the exact same effect. Good. Now, also just put this one in here. Now, this one over here is going to come out to, well, fairly close to where we are, and we're going to say trim it back so that it clears at least about 25. Cut with a line, grab it right there, cut off this piece, and then I'm going to move it perpendicular. So just grab a line, stick it between these 2 points, move the line a little bit out. Well, move the line out, not the actual cut. Just get the cut back to where it was. And then I'm going to say, right, that's enough clearance for our crawler that runs underneath. And then I'm also going to shorten this crawl beam up to the point where it no longer cuts that little area over there. Basically, to where we've got our web as a straight piece. Go. Now, as for the connections, this one over here is fairly simple. we're simply just going to grab these points, move them out by about 5 millimeters each. Actually, move them out by a millimeter each, as we do not want to create too much of a gap for when the core comes around in this area over here. Next, we are going to put in some bolts as soon as we take these and drop them down. Grab that, change front to behind. There we go. Now, onto the bolts. For that, I'm going to need to get the center point again and head on over to my bolt command. Bolts on a splice like this is very, very simple. We would like about 4 each side. As this is a 203, I need about 2 M20, and the distances really are going to depend on the size of the bolt. So in this case, if we use an M20, we can go about 70 with a, let's see, 70 cross centers, and that should give us correct spacing and everything else that we need. Now, as I said, this is very determinant on the amount of weight forces that are applicable to this crawler, which is going to be determined by the beam size and a few other calculations. So this process is very iterative. Yeah, keeps changing. You're basically going to put in your bolts. You're going to work out according to your count. Basically, what an M20 or an M16 bolt can take in tension and shear. So, for example, this would be in tension. The amount it can carry being pulled down is 156 kilonewton per bolt. So each of these about 300 kilonewton just for these connections. If you need more, you'll either need to add more bolts, make a bigger connection. If you can't add more bolts on this size, you might go down one size but get more bolts in exchange, and so on. For these ones over here, I'm going to say, let's grab that, get back to the top view. I'm going to say, right, this is good enough for that one for now. But for this one over here, I would like something a little more sturdy. Again, it's just an example. So, what we are going to do here, firstly, is create a view by 2 points to get ourselves a view on the side. This will look smaller. Over here. And we're going to get our extra bolts in by putting a plate over here with a stiffener. In that case, let me just quickly grab a line. We're going to say, using the standard, which is a 35 for a 70 cross centers on this bolt, on this beam size, and we're going to have to put in another set of bolts about 70 out. We're going to have an edge distance of another 35. Alright, so if we go to steel, from this point to where it should end, we're going to add a plate that should be about 130 wide, as this is 133, and 8 thick will do, as our flange over here is 7 point something. let's see, 7.8. Now, you can use a template, not a problem. Usually the easiest one to work with or to work out, but I prefer to have it roughly the same as a flange, and then I know it will roughly carry the same amount of force. Once you're done with that, put in a nice stiffener plate to keep this in place, and add some chamfers to the edges, the top and the bottom. For our galvanizing process. After that's done, grab these two, put in your first set of bolts, just quickly get back up here. I'm just going to reload my M20s, get rid of the previous settings, put that in over there, grab these two, put it in over there. And because they're on a 203 by 133, I get a 70 cross. And there you go. That'll be the stiffener on the one side. And this is how you make your area on your splice bigger enough to hold the crawl. Well, just do this by one each. Now, it doesn't have to be one, you can even go for 2 or 3, as your crawler can handle spaces about 5 millimeters. It really depends on the size of the crawler, as it'll depend on the size of the wheels that are running inside here. So, a little bit bigger, a little bit smaller, doesn't really matter, as long as you don't go too big. Even 10 mil is not going to be a problem in the short term, but after years of continuous use, it can cause a divot and a weak spot. If site welding is possible, then you might want to look into welding up after the connections are done. Let's just say copy rotate, get that around to the other side, grab everything except the beam, and on back to the previous, and then copy it over to the other side. Now, these ones over here, much easier, as we do not need to worry about the extra plates. 4 bolts will be enough to hold them. Well, that should be good. And what we are going to do here, simply just put a standard set of bolts in. I'm going to say minus 35, 70, 70, and that'll be good enough for this one. Just copy that over to the other side. Now, the other problem you have with this crawler is that without something to stop it, it's just going to run straight off the rails. So, we're going to head back over here, and we are going to put in a stopper. Something to stop it in its tracks, in case it keeps running. And that'll be just from the top to the bottom. A piece of angle line is usually sufficient. Now for this size, I'm going to use a 7070 by 6, but you might want to look at something bigger, again depending on the size of your crawler. Usually stuff like this can be or will be determined by the engineer himself. If he doesn't give you any specifics, put something in that's fairly close that can work, and then he'll have to either approve or tell you what he actually wants in there. Just going to do that, grab it again, and I'm going to say 140. Move this down by 45. Good. Now, I just need enough clearance over here for the rounded edge at the bottom, that radius which is 7 or 8. After that, just grab to the 3D. It's going to move to the side a little bit. Just grab and move. And we are going to mirror it over. Got a special mirror. And that'll be it. Now, one of these is usually welded to the frame, and you're never going to use it. The other side, on the other hand, needs to be bolted so that the crawler can be removed if and when needed. And at some point it will need to be serviced, so an easy way to remove it is preferable. Good. Let's change this to top. This is a 70, so 40 back mark. And it's a 140 long, so 70 and 70, or 35 and 70. It's going to give us 2 bolts nicely spaced. Now this could probably be an M16, no problem, but as the rest of the stuff are all M20s, I'm going to keep it M20 just for the sake of consistency. Good. Now that that's done, we can grab that and just copy it on over. And we are basically going to do the exact same thing over here with this one. Now with this one over here, I'm going to do 2 things. I'm going to do a regular splice somewhere inside, and then I'm going to do a welded splice. Let's have a quick look at a nice side view. Now, for the welded splice, basically we're going to have these two overlap each other. And I'm going to say about 350 should be fine. And again, you will need to have the specs for this, the kilometer and the forces applied to this, and you have to work it out accordingly to make sure that it is actually strong enough. All the engineer needs to do it if he does not want to give you the forces. So we are going to do a poly cut, and we're going to cut out this block here at the bottom, and we're going to do the same thing for this, just do the other side. This gives us a sort of jigsaw with how the two fit onto each other, and this is a fairly strong splice, and it's usually what they use when a beam is too short. So if they've got something like an offcut or a couple of offcuts that make up the length needed, they would rather do something like this instead of purchasing an entire new section, using a new section. But some jobs it is not allowed. It really does depend on a couple of things. Now, as for this one over here, we can go and have a look at the splice connections. Now, there's a lot of beautiful splices, and something like this where you've got plates both sides and in the middle can work quite well, except for a case like this where we've got a crawler running through, which means we cannot have anything on the bottom flange or on the bottom area of the top flange. So using a normal splice like that can work with a few minor modifications. I'm going to start off by using the splice connection number 77. Open that up. Now, for the amount of bolts, I usually use the beam size. Give me a good indication. Something like a 203 beam would use 2 rows, in other words 4 bolts, and for a splice on a 203 beam, I usually would put in 4 bolts on the flanges, per side that is. So let's start off with a bit of a clearance over there in the middle. I'm going to head on over to plates. Let's do the bolts first. And say, right, we want one of those. We're going to have a 70 cross centers and 30. Let's just have a look in 3D what it looks like. Right. Now for the inside plate, we are going to need an inside plate, but let's ignore that for now. As well as the amount, I said 2. Let's do a full bearing area. Now, the thing with the splice or with connection strength is the closer the hole is to the side, the weaker it is, obviously, up to 3 times the diameter. So as long as this bolt is 70 or 60, this is 1020, from the edge, it is at its full strength on what the material can handle. So let's take that at 70, 69, since we've got the 1 millimeter there. That's going to be about 35. That's going to be about 70. There we go. Now, as we are going to be carrying the top only and not going to do anything at the bottom, I'm going to increase this to 3 to make up for that little bit extra there. The web plates, I'm going to say, 35. I'm going to say only 1 row. And I'm going to make these 70 from top. Let's say less than that. So 50 from top. And you'll need to get the specs on your specific crawler to get the exact amount over here, so that you know how much clearance you need to give, or where the crawler wheels are going to be running, how far out it's going to come, all that stuff. Over here I'm going to say, let's see, 34. So you're going to need 3 as well, 35 at the back, and 70 over there. Let's make this 4. Now the reason I've done this is so that I've got these staggered. I don't want them straight across to make a line of weakness. I want them to be able to take a little bit more, so staggering is always a good thing to do when splicing. Never have the flange and web bolts in line. Now, next thing is the thickness of the plates, and this can be quite a difficult thing to do, but there's a fairly simple rule of thumb usually that works quite well, and that is area. The area of your plate should be equal to or more than the area of your beam. So in a case like this, let's just explode that, get rid of these on the inside. We're going to say, right, the area of our beam, for example on the flange, web, is going to be 7.85 multiplied by 187.6, and that's going to give you 147,472.73. Let's go with 73. Then the plates, that's these little ones over here, is going to be 6 times 70 and times 2 because we've got 2 plates. So that's going to give us a total area of 840, which is less than our web, which is less than ideal. So what we're going to do, this one over here, let me just make that a P, is we're going to change this to a 10 thick plate. Now what is that? Well, that beefs up our area to 1400, which is almost what we actually need in order to sufficiently keep hold of this web. Now, it doesn't work 100%, but it's close enough for this one. Usually that's roughly what the engineer is going to be looking at in his calculation. It's just a quick check that works out some of the time with the other calculations, but not always, and especially not with crawler, as we are not evenly distributing the load we should be distributing. Or more specifically, most of the weight is going to be hanging on the bottom and the splices on the top. Right, so our flange is about 1000 in area, times 2 because we've got everything else to make up for as well. So we've got about 2080 to well, area in flange. Then our areas for our 2 plates at the top. Well, our flanges, I said 2080. So these 2 together, or these 3 together, is going to be about 2500. And that is sufficient for its specific area. Not really for the entire beam, but for this specific area it is sufficient. Now, we'll probably need to do a few more things to get it to be completely sufficient, but usually that is going to be determined by the weight of the crawler, which we do not have. So for now, this is about as far as we can go. And that should be about it.